and then later on it doubles them, so it becomes 4 and 6. But then when I go back inside the main event, x and y is still 2 and 3. So what that allows you is a little bit of protection that basically the procedure won't change the values in the main event that calls it. So here's the area that calls it. Okay, this is up here. This is what we call a call to a subroutine. And I'm calling x and y. And by-val, it makes a copy of it into I and j. See down here, this is the new variable, I and j. It makes a copy of the value. That's why the by-val, it makes a copy of the value into the new I and j. And then it doubles them. So inside of the sub-procedure, they're double. They get changed. More or less inside the sub-procedure, you can change the value. Then afterward over here, I have another procedure. It's almost exactly the same thing, except I use by ref, okay? And by ref, actually, so down here, if I say by ref, the double by ref, and note I call them I and j. I and j actually point to those. They're pointers that point to these same memory location. So when they make a change, they make a change in that same memory location, so that when I go back to the main guy that called it, it's actually changed, okay? So that if you look at this here, you see here I'm back in the main event and they didn't get changed, they're still 2 and 3. But now I go inside the one that's double by ref. And the double by ref, first they come in as 2 and 3, then they get doubled. And then it leaves the by ref and comes in, and you see that in the main event, you go ahead and have the doubled value. They did get changed. Because the by ref, it's a reference to that same, you can think of it as a reference to that same memory location, okay? So by ref is a reference to the same memory location, so it changes the actual value over here. By val, it makes a copy of it and works on it, okay? Any question on that? And the main thing is, if you think of a function can return one value. But if you make a procedure that has to change a bunch of value, then you have to go ahead and basically use the by ref. If you want to make a calculation and change a bunch of value, you use by ref so that you can go ahead and change it, okay? So if you want to change a multiple, like 2 or 3 values, by your procedure, you use the by ref, okay? Usually you use the by val. Any question before we go on this? Everybody understands this real quick? Really? Everybody understands it? And so you have to be a little bit careful. Where could be, so in a test, if I have basically one of these that has a double like this, and this one says by ref, you know that the value will get changed in here. Well, the by val, it wouldn't change the value, okay? So you got to watch that a little bit for your testing quizzes. So let's take a look at the other, the complex math. Okay, complex math. what we're going to do is we're going to make a little calculator that can add two numbers, subtract two numbers, and multiply. That's supposed to be a star. I don't know if you guys see it or not. Okay? And we'll go ahead and do that together, and we'll use subroutine and we'll use function, and you'll see how they both change differently. Okay? If you look at the code right now, whoops, I opened the wrong one. I opened the one that's got all the code.
Lovely.
No, that's not what I want. Where's the one that says start? Okay. If you look at it right now, here's the form, and it has this code on here, and it has one function in it. Get complex number. We kind of did this code, if you remember back when we did the parsing of the complex number, where we would take the real part, look for J, and get the imaginary part. Okay? And we did this code here. So I basically grabbed the same code, put it inside a function, okay? And this particular function, what does it return? It returns a Boolean. What's a Boolean? True or false, okay? So basically, I'm using the true or false to be able to go ahead and indicate that it got a proper number. Remember that basically, if somebody enters 35J25, there's no sign here. If it gets put a plus or a minus, I don't know the sign. So this would return false if the user entered a wrong value like this, or if he entered something that's not a proper complex number. Okay, so we did this a little bit back. We basically look for the J, split the thing up among the J here, and also look for if there is a J, if there's a plus or minus. So this guy here will return a Boolean that says true or false. So I can go ahead and make an if statement off of this guy. Okay, and then it uses by ref and for real and imaginary. Because wherever I call this function from, I wanted to get the real part and the imaginary part. Okay? So let's take a look and do this. So let's write the code. So let's double click on the plus sign. And let's move this code up the top here. It's kind of the bottom. And I want it up the top. So I'm going to cut it and I'm going to put it up here, right after class, okay? I moved it here so I can look and see this guy down here. I want to be able to see who I'm going to use here.
What did you move again?
I moved these two lines from the bottom, because when you double click on it, it adds it way down the bottom, and I moved it up the top. Make sure that you only move those two lines. Okay. Yeah, I just clicked it. You can click and drag or cut and paste. Okay. So I put it up here. So we're going to have two real numbers. And how does anybody remember? Does anybody have the? Let's say if I have, here's my real, my imaginary number 1. If I have 35 plus J25 and add to it 25 minus J15, then you just add these together, and this one here would be plus J10, okay? So basically we're going to add a little click button event that does this. So the first thing I need, I'm going to need two variables that's going to hold the real values and two variables that holds the imaginary part. So let's declare those. Okay, let's make, so dim, real, 1, real, 2, and imaginary 1, imaginary 2 as doubles. Okay. And we're gonna go, this is complex number 1 and complex number 2 that we're gonna get from the text file. Okay? So we're gonna make it complex number 1 and complex number 2. What kind of number should we make them? Anybody? A string. Okay? Because that's a string. It has a J in there, it's got the plus sign and all that. So we can go ahead and assign complex number 1 to text value 1 dot what? Dot text complex value, value 2 is equal text value 2 dot text. Okay. So now I'm grabbing these two numbers. And basically now I want to get the real part and the imaginary part of it. Okay? And I have this nice little function that I have, that I made, so I could go ahead and get the imaginary part and the real part. So let's get those. And because this one returns a Boolean here, I can make sure that the values are okay. Okay? So I can actually go ahead and make a if statement, if get complex. You see complex shows up down here? Because I wrote this procedure, it shows up. You see this little purple box? That means that's a procedure that I can use. So complex. And then what am I going to put here? If you look here, it kind of tells you the first thing it wants the complex value. And it wants it as a string. You see, that's the first argument it wants here. It wants an argument as a string. So we're going to make it complex 1, comma, and then the real 1, we're going to put it here, and imaginary 1, okay? So I'm saying if this number is okay, and if the other number is okay, then I can do my addition, okay? So I'm going to put and, whoops. Get complex 2 this time, real 2, imaginary 2. Then I'm going to go ahead and get else. I can go ahead and put an else statement. I can put a message here saying value, one of the value not valid. Okay. Yes.
I am not able to find where you moved. I've double clicked on the plus, but I don't see at the bottom the
Lo vas a hacer después de esta clase. Lo vas a hacer después de esta clase. ¿Tienes? Tengo.
How do we open it again?
Okay.
Is there any other one? Let's do
Oh,
that.
it's in the back there. The other one.
Yeah, the other one.
That's weird.
That's by
That is really weird. That's really weird. So now, in here, so before here, real 1 and real 2 and imaginary, they're 0, okay? They're 0. Once it hits this get, it goes down inside this, this function, and then after, when it comes back up here, real 1 will be the real part of it, the imaginary part will be inside of here, and the complex part is here, and the real parts are all there. So it goes out, it returns to me a true or false if it's true, but it also returns to me inside these new variables, because I didn't buy ref, it returns that new value. What question do you have? Do you have a question?
What is the then statement up there for, after the get complex components?
That's part of the, and then we do what? Then we gotta go ahead and add this code here, okay? Where we're gonna really do the add addition, right?
We have to keep the order for complex to real to and emerging to. Do you mind like if you change it, the order, like we start with real to comma, yeah.
Oh, this over here, that one over there?
Yeah, no problem. And then also
These have to be exactly matching the
okay.
order. So you gotta have a string to begin with, you gotta have real, okay? And then you gotta have imaginary. If I switch these two here,
yeah.
I would get the real number inside the imaginary, and I would get the imaginary inside the real. So whenever you make a call statement, it has to match the name of the function, and it has to match the number of arguments. I have 3 arguments. It has to have 3 arguments, and it must be the same type. It's got to be a string, it's got to be a double, and a double. Okay? So now we get, let's add over here, to make it a little clearer, real result and imaginary result. Okay, so we'll put that inside of here. Is it doing okay with your sub there? Are you getting it?
Yeah, it came up that time. I don't know what happened the first time.
So the real result is going to be equal to real 1, real 1 plus real 2. Okay, and real imaginary result is going to be imaginary 1 plus imaginary 2. Okay, so now basically I have my result, and I have 1 and 2. And now I want to display it out in the text box, and I want to display it as a text, as a string. You know, I want to say, here's the real plus J, whatever, okay? So now what we're going to do, we're going to write a little procedure that does that. Okay? We're going to add a little procedure that does that. So here we'll go ahead and we're going to call this, we're going to use a sub this time. Because this guy will not return anything. It will just it'll display it, okay? So we're going to call it sub display complex. Okay? And now we got to give it the argument. So we're going to give it the argument of by, which one should we do? Should we do by val or by ref? Huh? By val, I heard by val. Yeah, by val, because we're not really going to change the value. We're only going to go ahead and display it. So we only want to go ahead and make a copy of it and make sure that we don't change it. So we're going to say real as a double, okay? And then we're gonna do another bival and imaginary as a double. And here we're gonna do something a little bit interesting, and it's not in the book. Well, we're gonna go ahead, we're gonna put text box output as a text box. If you see right here, as a text box. So not only can I go ahead and say, you know, real, imaginary, double, I can say it's a text box. I'm passing to you the name of a text box. So I'm going to pass the name of a text box inside of here. And over here, I can go ahead. What am I going to look for? I'm going to look for, if I want to put a plus or minus over here, so I'm going to look to see, is it bigger than 0? If the imaginary part is bigger than 0, I'm going to add a plus. Okay? So I'm going to check on the imaginary part. So let's say imaginary here, greater than 0, then, okay, then I can go ahead and say text output dot text, okay, is equal to, we're going to convert it to string, right? And we're going to grab the real part. And then we're going to concatenate it with a space plus J, because, whoops, plus J, because it's greater than 0, right? And then we're going to go ahead and give it the convert string, put the imaginary in here. Okay. Else, I'm gonna do this one a little quicker. I'm gonna copy, paste it, and make it a minus. Okay? So basically, it's gonna display the minus. Okay.
How did you get that subroutine right there? This value that you're working on right now. Where did you get that?
I wrote it. We just wrote it. So started typing out sub, space, display, complex, typed
So
all
this
this.
wasn't something clicked on, okay?
No, this is something you remember the other, this sub over here is basically generated for a click event, and that's how you can tell the difference, because it says it handles a click, button click, okay? This one here, it's not an event that it handles, it's just a subroutine by itself, okay?
So does the by val, is that the one that allows you to change it, or is that the by ref?
By value, it grabs the value, copies it, and uses it. So in here, if I wanted to, in here I could change the real, I could double it or whatever. Well, hopefully I'd do that after, whatever. I could do stuff in there, and it doesn't affect the value inside over here, okay? By value. And I don't want to change it. This thing's just going to display it. So let's see if our little guy here works. So if I click my plus here, oh, okay. I didn't call it. See this subroutine sitting there. It could work, but I didn't call it up here. I didn't invoke it. So in my click event, it never evokes it. So how do I invoke it? Display complex. So I call the subroutine and I pass it real result. and I pass it imaginary result, okay? And then I pass it the name of the text box that I want. Whoops. Where's the text box? Here, text box result. Okay. So now it will call down here. Note that the names of the variables don't have to match, right? Because here I want this to work for any case. So here it's going to call it, it's going to pass the result, these two results, and then it's going to display it in my text box that's called text result. If you look in the form, that's the name of that. There it is. Okay. So now I call it, so after it adds these two values, it's going to display it inside of here. See, and it adds it. So 35.2 plus 20.3 is 55.5.
Minus J minus 11.
Minus J, minus, oh, yeah. So what do I want to do? After, since I'm going to put the minus here, what do I want to do over here? If I take imaginary, multiply it by minus 1. Okay? So that the value, because it is, I'm putting the J in here in front of this. So basically, it's already there, okay? So, any question on this before?
So the by reference can change those, it's not doing the same, so, at the point.
Okay, so by val here,
No, I know we're not using it.
right, right, so by reference would actually go ahead, the new variable inside the function points to the same memory location, so whenever it makes a change to that original one. Okay, here I'm making a change to imaginary, but because it's by val, it's a copy of it. So I'm not changing the original one up here, okay? That makes sense, that's your question?
Yeah, just, if it can change it when it's not in the same function.
It can change this guy inside this function, okay? I can change that guy inside this function, but it won't affect whoever came in into it, okay? Because here you see here that I'm changing it, okay? But it's not affecting this IM result up here, okay? So let's go ahead and basically make a version of it that does for subtraction. So again, I'm just going to grab this guy here, or bring it up the top. Okay, and I'm going to be nice and lazy here, and hopefully I'll make all the changes. Whoops, I wanted a copy. So I copy this, and what do I do here? I just do minuses, right? I just do minuses, and that's all I have to do.
So you just copy and pasted?
Yeah, I just copied my code from the add into the subtract, and then I just went and changed the equation here to minuses. Okay.
You have to change that times by -1 now?
No, down here, the result, if it comes out a negative number, it'll still work down here.
I mean your output.
Huh?
Remember that, the display complex?
Display complex, it's gonna, no, I don't need to change anything else because this here, IM result is gonna get the negative of it, and that's gonna get passed, so let's test them out. Okay. So let's do a minus here.
Can you see the code again?
Program, chapter 5. Complex math.
So you see here that this minus this, so 35 minus 20, I get the 14, plus 45, minus a minus 56, so this becomes a plus, so these two numbers are added and they come in there,
Boom.
okay?
I really error message on my phone. Subtraction.
I know how to do it, I just, I don't have the time. I don't have time to do it. 'Cause I was trying to use parallels at first, but I couldn't do parallels to work, so now I'm just using bootcamp.
Oh, it's got multiple definitions, go all the way down the bottom or someplace, it's got, go all the way down the bottom.
Sounds more
It's
realistic.
right there, delete those two.
It's not hard.
Okay, careful. You have to put it back in, yeah.
So
Functions,
Okay.
it's saying
but different ways.
my display complex is
Okay.
janked.
Huh?
It's saying that the display complex
Okay, look.
has identical signatures, and I'm looking for.
You don't copy a display complex, okay? When you copy and paste, make sure that you don't make two copies of display complex. I'm using the same one. That's the advantage of using subroutine. You make a nice little subroutine, you can use it multiple places, okay? So now we want to go ahead and do a multiplication. And let's bring them up to top here. Probably when you did when you moved the copy and paste, and let's put them up here.
Copy
Can I
change.
just cut it?
Yeah, cut it and paste.
And
Don't
hence.
copy, because then you leave the other one there, and there'll be two of them.
Could you print off the real quick?
Enhance.
I'm still getting to the very bottom, I haven't done the minus yet.
Do what now?
I am in the sub display.
I don't know, will this work?
Copy class, red class.
You trying to print? Enhance.
All right, let's try
Thanks.
it.
Let's try it.
So,
Do something, just copy the,
Minus.
target cell.
Perfect.
You just copy paste.
Yeah, I
not,
changed.
not quite,
the
we
real
can copy
one,
some
minus
of it,
real two. This is
right?
real one.
we can,
So do you have it? Okay. Subtract it. Yeah.
why not?
That should work.
Let's copy a good amount of this
I
here.
haven't done it
Front
quite yet.
row.
Oh yeah.
Can you print
Oh,
one, copy?
I want to shoot some.
Make that two.
Sure. Print the whole class one. Why not?
Okay.
To the base.
So here, we're gonna have to really change basically these here. These basically for multiplication, that's not the case, our multiplication works. Let's first talk a little bit on how multiplication works. Anybody remember?
You multiply like terms together, or would you have
Uh,
to? Would you have to
no.
foil it?
Huh? Yeah, I sent it. Did any come out yet?
I got mine. So it worked the first time.
When you multiply it together, would you just have to foil it? Just like
Here goes. Okay.
multiply
So-
the first terms together, middle terms.
So you have basically, let's say we have
Complex
real,
number.
plus J imaginary, right? If you want to multiply it by another one, okay, the easiest way to do, this is called rectangular format. This is rectangular format. Polar format is a magnitude, let me call it a magnitude A at an angle, okay? Because remember, this is basically what this is telling you, RE, this is the imaginary plane, this is the real plane, and this is a point right there, okay? And I can go ahead and represent this by a magnitude and an angle, okay? So, and then what we can go ahead and say is that the magnitude A is equal to the square root of the real part squared plus the imaginary part squared. That's the magnitude. So remember, this is a triangle, Pythagorean theorem, okay? And then the angle here is equal to arctangent.
Is it real or imaginary?
Here it is. Arctangent of imaginary over real. Right? And then if you want to go the other way around, the real is equal to A cosine the angle, and imaginary is A sine the angle. So we can go ahead and go between the two. So first thing we're going to do, we're going to go, and then what that does, then if I want A angle times B angle 2, then the result of that is A times B at an angle of, let's say, theta 1 minus theta 2. Okay? So that'll be our equation that we want to put over here. So what we want to go ahead and do is make functions that basically make procedures that does this here, the conversion. So let's write a procedure down here that writes the conversion. So let's do sub, because we have to do, our procedure has to return two values, we're going to use sub, and we're going to use the biref to be able to change them. So sub rectangular to polar. Okay, and then we're going to do a bi val, and let's do real as double by the imaginary as double. And so we can see it all. I'm going to put it kind of on the same. If you hit a space right after a comma like this, it'll put you a second line. Whoops, but I probably just messed it up. If you put a second line here, you can continue. Basically, you're continuing the value. And these will be by ref as, whoops, I changed magnitude. As double by ref angle as double.
So by ref is because we change it, right?
Because we want to be able to, wherever I call, to be able to give it its result here, okay? So which one did we do? We did the rectangle. So magnitude is equal to mat. We're going to use the mat class, the square root of. Okay, that's one of the math class functions, the square root of. And we're going to do real. We're going to square it plus imaginary, and we're going to square it. Whoops. Error. Okay. And then we're going to do the phase. Now, the math function like to work stuff with radians, so we're going to have to convert its results. So math and arctan, arctangent. This is the arctangent, right? So arctan is the arctangent. There's two different arctangents. I'm just going to use this first one, and this is imaginary divided by real part. Okay, and then this is going to be in radians, so I want to convert it to degrees, so I do 180 degrees divided by math dot pi.
Do you have to declare phase somewhere?
No, I changed the name. It's angle.
That's what I thought, yeah.
It's angle. Thank you. I would have gotten a look, because I have a strict and explicit on, I would have gotten a little message saying it wasn't declared. Okay. So I have this guy here, and so that would mean that to get this guy, I would have to first convert it right here like I do here. Okay? But if I want to, I'm going to show you a little something else that they don't show to in the book, which is called overloading a function. Remember some of the function like a dot show for message? You've got a bunch of different ones that you can do. You can do some with just a message. You can do some with a message with a title. And you can do some with icons and all that kind of stuff. Basically, we're going to go ahead and do that same effective stuff here. And we're going to do sub rectangular. We're going to call it exactly the same name, rectangular to polar. But this one here, we're going to make it a little bit different in that it's going to accept a complex as a string. Then it's going to have the bi-ref real as double, and bi-ref imaginary as double. Okay. And this one, the code will know to use this one if it has only three arguments, and the first one's a string, so it can tell the difference between the two when you call them. Okay. So this one here, so I'm going to do a dim, real, imaginary as double here, and then I'm going to go ahead and call the get complex, comma, real, imaginary.
It says that real is already declared as a parameter of this method.
Oh, okay, yeah. Oh, what is it? Oh, I know why. This is not, I don't want, this is rectangular to polar, so this guy is rectangular, so I want this one here, I made the wrong name, magnitude. Okay. and I want this one to be phase, okay? Angle. Thank you. So I'm getting the real and imaginary because remember this is a string here and I'm getting these here. So I'm going to get the results right inside of here. And then all I have to do is call the other guy. I already have a rectangular, two polar. I can call that guy polar. Is it on there? So what is rectangular polar? You see now, because there's two of them, it shows me that there's two down here, one of two, okay? Because it's overloaded, it has one of two, so I can go ahead and look at, see the other one wants a real, wants the imaginary part, it wants magnitude, which is, what do I call it? Magnitude, and it wants the angle. Okay. So this will allow me to grab the guy right off the bat and not having to convert it first, because this guy will do the converting it to real imaginary, and then he'll go ahead and just call that one. So I have two. So it just to show you that you can go ahead and basically do overloaded functions that you can do with. But the overloaded function, the number of arguments or the type of arguments have to be different. Okay, when they're overloaded, they have to be different. You can't make one exactly with the same number of arguments and the same type of argument, or it won't complain. It'll say it's already defined. Okay. Any question on that? On how you overload? You can overload a function. So over here now, instead of calling this guy, I can call the other one. I don't know. Let me see if that's. Try this. So up here now, we can go ahead and try to go ahead and add all our text here. So we can go rectangular to polar. Now we're calling it, okay? So real one, imaginary one, and now he wants the magnitude. Oh, I'm going to need to go ahead and define magnitude 1, mag 1, and angle 1. Okay, so I need to go ahead and add those up here. So let's do a mag 1, mag 2, angle 1, angle 2 as double. Okay. And then I do that for the second one. Oops. Real 2. Oops. Real 2. 2, so now I have them in this format, and now all I do is I take for my result. Oh, I should have put the result up here. Mag result. And angle result. what do I want? Mag result is equal to mag 1 times mag 2. And angle result is equal to angle 1 minus angle 2. Okay. Now I need a polar direct angle, right? So I need to do this here. So I need a polar direct angle, so I can write here a sub polar to rectangle.
What happened to real 1 plus real 2 and imaginary 1 plus imaginary
He
Yeah.
deleted it.
Real one, which real one and real two?
2? Like where you're putting the rectangle to polar. I still have like the real result and imaginary result. That's the next one.
What's that?
Did that get moved down so far?
I don't understand what you mean.
Right there on where the if get complex components.
Right?
I have all that, and then where it says then I go back and I start having real result, real 1 plus real 2, image result, image 1 plus image 2.
Oh, that's the, from the before, that's the, that's, we copied and pasted,
Slow it
delete those lines.
Okay.
This is, this was from, we kind of copied the code from the plus,
Right.
and we put it up there, but now we've got to change it, because it's not just adding, we have to do this. Okay. What was the other question?
Isn't it, aren't the angles added when they're multiplied and then
Oh,
subtracted?
that's
saying.
right.
Subtracted when
that's
they're
right.
divided?
That's right. Thank you.
Mega.
This is division, I just did division. Right? As far as the angle, it was doing the division. Thank you. Why is it complaining real?
Still adding.
Did you have to declare your mag 1 and your mag 2 somewhere earlier? Oh, I see. You
I
did.
put them up here.
Yeah, I see. I just skipped that on accident.
Why is it not grabbing, oh, it's upset down here.
No.
It's because I haven't finished this here. I haven't finished this one. So, what do we want here for polar to rectangle, bivalve? We're gonna grab the magnitude as double, and bivalve. We're gonna grab, the angle as double, and biraph, okay, for the real as double, and biraph imaginary as double. Okay. See, those errors that show up was because I had started doing that guy, and I didn't finish it. So in here, we're gonna go ahead and, the phase, angle. Angle is equal to,
Is this a new?
Yeah, this is new.
we need to convert it to radian. This angle is in degrees right now, so I need to convert it to, radians. So I have to go ahead and do times math pi divided by 180. So I'm converting it to radians here because the cosine and sine work off of that. Okay, so magnitude times math class. This one's the cosine, my angle. And the imaginary part is going to be equal to the magnitude mat sine, whoops. So now I've got that little function, I can go ahead and call them up, polar rectangle with a magnitude result, my angle result, whoops, angle result, and then the real result, imaginary. Oh, I've got a document.
So you had to do a new subpolar to rectangle?
Yeah. That's the one that we just did down here.
Yeah, okay.
Okay. Okay. And that's our multiplication little guy. So we kind of learned in here these math functions, reinforce those a little bit, the math cosine, we did a little bit of polar. We learned the main thing were the bival and biref, how different you use it when, okay? Like in my polar to rectangle here, I want this real that I'm going to calculate to be able to be available up here. So I have to make a biref so that I'm changing the actual value inside of real result. Okay? Any question on that? You want to see if it works?
Can you turn off that finished code? I was just trying to follow along. I got behind you.
I'm going to go ahead and put up a copy of the finished code.
Oh, okay.
Okay? I'm going to put up there a finished copy. So there's the start right now,
Yeah.
and I'll put up one that doesn't say start. It'll say just complex math. Okay?
Okay.
So that you can look at it. So, yes? Okay. Let me just, so here's a multiplication. Multiply. Yes? Let's hold on a minute. That's because where's your
What up? Oh yeah.
you have to,
Oh okay. I know that. Cool.
it's like there's a
Yeah.
matching in.
The mint?
That's what I was looking at.
I didn't know that. I've never had phone in my hand.
Sometimes these darn error things, they kind of stick around.
Same thing?
Let me look at it a little bit more. This will take a little bit more time to look to see what happens.
I
Okay?
get what you're saying. I didn't.
So you guys get a feel of the function versus a sum?
Can I see the end of that biref IMG? I just wasn't sure what's after that. Couldn't. Oh, it has double.
Yeah.
That's it. That's it. That's all I want to know.
Imaginary result comes last.
Okay. And any question about these sub and not sub functions and bival and biref? Okay. One thing to note here, a sub, you see all these sub here? I just have the name. I don't have a value equals. This is almost like a value equals here. This will return a true and a false. Okay? And did everybody catch that? This is a very useful method of using a function, having it return a true or false, so that when the function runs correctly, it'll return a true, and then your code can go on and do what it's supposed to. And when a function that does something that it's not quite right, it can return a false, and then you can catch it in here. Okay, don't forget that that get complex number returns a true or a false, and it also changes these two variables here at the same time. So I can catch it, okay? If you look, let's look a little bit more. Take a look at, see, here's this get complex. See this Boolean here that it returns? You see here that he uses a Boolean flag. It uses a Boolean flag that it sets true or false based on something didn't happen quite right. So in this case here, they forgot to put a plus or minus sign in front of the sign. This would go ahead and set the flag to false, and then way down the bottom here, it returns the flag. So, like, let's say if I run this guy here, and I don't put a plus here, and I try to activate it. Whoops,
You want to look at it?
it didn't.
Yeah.
What happened?
So,
If I take this, wait a minute. It's supposed to go ahead and tell me you used to. What did I do?
negative some crazy fucking number.
Hold on a minute.
Are you using
I must
35.2?
have a little something.
Negative plus 2? Let's compare.
What's that?
Bring it to closer sets. Okay, wait. Is this your application? Go up a little bit. Go down a little bit more. This one you see.
Okay, see, it finds that there's an error here, and it goes ahead and indicates that there's an error in the complex.
Angle
It's
1.
not valid, so it doesn't,
There's a minus.
do the
Let's see.
thing, okay?
You edit it. Is your program running?
So it catches, it returns a false in that if statement, and then it knows, don't add these numbers, there's
Look at
something
your
wrong with it,
stuff down here.
okay? Okay, if there's nothing else here, any questions?